This video begins to develop the machinery for models in QL. We saw in the last video that in SL, the formal structure which determines the truth value of every sentence is a truth value assignment to the sentence letters. You can think of it as being like a horizontal row in a truth table. Philosophically, it corresponds to a way that the world could possibly be. In QL, the formal structure which determines the truth value of every sentence is a model. Let's take a step back, though, and consider what happens when you're translating to QL. Here's a symbolization key that's like one we might have used in previous weeks. Let the universe of discourse be islands that I have listed in my notes. Let UX mean X is in the USA. Let FX mean X is in France. IX means X is an island. JX means X is in Japan. Little c is Crete, and little m is Manhattan. If we consider the sentence is it true or false? Well, it says that Manhattan is in the USA, and that's true. Note, however, that recognizing that it's true requires more than just knowing what the symbolization key is. You have to know a little bit of geography. What about for all x, ux? Is it true or false? Well, it says that everything in the universe of discourse is a u. All you know about the universe of discourse is that it's islands that I have listed in my notes. Since you haven't seen my notes, you can't know the whole universe of discourse. However, the symbolization key also has constants for both Crete and Manhattan. QL is constructed so that every constant picks out a member of the UD. So you know that Crete is one of the islands that I have listed. Crete is not in the US, so for all x, ux is false. It's not the case that everything in the universe of discourse is in the United States. What about exists x, fx? So the universe of discourse is islands that I have listed in my notes. Fx means x is in France. And there are islands in France, even if you can't name any of them off the top of your head. Maybe I have one of them listed in my notes. You just can't say. Just from the symbolization key, you don't know if exists x, fx is true or false. What we want to do is merge this symbolization key with facts about the world to give us a formal structure that actually makes things true or false in QL. The universe of discourse is a set of islands. It's the islands that I have listed in my notes. Specifically, those islands are Crete, Manhattan, and Oahu. Now that I've written them down as a collection of objects, you know what we're talking about. The fact that they're listed in my notes doesn't matter anymore. You know that the universe of discourse is these three things. Quick mathematical aside. A set is a collection of objects offered in no particular order, and it's standard to write a set in curly braces, like the ones highlighted and pointed to here on the slide. And then we put the members of the set in a list, and we separate them by commas. So the universe of discourse is a set of objects, the set containing Crete, Manhattan, and Oahu. Now, UX means X is in the USA. There are two things in the universe of discourse that are in the United States. There's Manhattan, and there's Oahu. It helps to have a word for this. The extension of a predicate is the set of things in the universe of discourse that the predicate applies to. In our model, the extension of U, extension of the predicate U, is the set containing Manhattan and Oahu. Fx means X is in France, but none of the things in the universe of discourse are in France. We could just write the extension of f like this. Just open curly brace, close curly brace. It's a set with nothing in it. In math, though, the set with nothing in it is called the empty set. It's usually written as an O with a slash through it, like the O with the slash through it depicted on the slide. And so the extension of F is the empty set. That is, nothing in the universe of discourse is an F. The predicate Ix, means X is an island. Everything in the universe of discourse is an island, so the extension of I is the same as the UD. We already specified the UD as a set, and so we can write it this way if we want. Extension of I equals UD. Or we could write it out again like this. The extension of I is the set containing Crete, Manhattan, and Oahu. That is, all the things in the UD are in the extension of I. Jx means X is in Japan. Well, none of these three islands are in Japan, so the extension of J is the empty set. Even though F and J meant different things in our symbolization key, they have the same extension. Both of them are empty. So the two predicates are interchangeable in this model. The fact that we will use them to translate different English phrases doesn't matter. Considering the things in the UD, F and J apply to the same things. Specifically, none of them. What about the constants, C and M? Importantly, a constant doesn't apply to a set of things. It names exactly one thing in the universe of discourse. Again, it helps to have a word for this. The referent of a constant is the object in the universe of discourse that the constant names. So we can write down the reference of C and the referent of M as Crete and Manhattan, respectively. Note that these aren't sets. I haven't put curly braces around them. Instead, the referent of a constant is an individual. This is the model which corresponds to the symbolization key we started with. With a model, we can figure out whether any sentence of QL using these symbols is true or false. We don't need to think back to what the symbols meant when we were translating. Exists X, Fx, our sentence from earlier, says that there's at least one member of the universe of discourse which is in the extension of F. Since the extension of F is empty, there isn't anything in the universe of discourse that's in the extension of F. So exists X, Fx is false in this model. The model specifies the universe of discourse as a set of things, an extension for every predicate, and a referent for every constant. Technically, there are infinitely many predicates and constants in QL, but we'll only ever need to think about partial models, ones which specify the extensions and the reference for the predicates and constants that we're thinking about. Truth in QL is truth in a model. Given a model, every sentence of QL gets a truth value. We'll see how these details work out in the next couple of videos.